You ever just look up at the sun and try to wrap your head around how big it is? I mean, we hear these crazy numbers, right? Millions of miles, thousands of degrees, but they're so huge they don't really mean anything. So today, we're going to change that. We're actually going to build it in a way that finally makes sense.
So let's just ask the question straight up. How big is the sun really? We see it every single day, but yeah. Let's start with those big, abstract numbers we all hear and see if we can bring them down to Earth, so to speak.
Okay, first up, width. If you wanted to go from one side of the sun to the other, you'd have to line up about 100 Earths, side by side. 100! To put that in perspective, if our planet Earth was, say, a little garden pea, the sun would be a giant beach ball, and that's just talking about how wide it is.
But here's the thing. Width is just one dimension. Let's talk about volume. How much stuff you can actually fit inside. You could cram 1.3 million Earths inside the sun. Just let that sink in for a second. Our entire world, every ocean, every mountain, every city, you could pack it away in there over 1 million times over. It's just wild.
All right, now let's talk about distance. This one's a doozy. Imagine you got the fastest sprinter on the planet, and you told them to just run towards the sun. Well, it would take them 500 years to get there. 500 years. That's centuries of non-stop world record sprinting, no breaks. And see, that's the problem, right? 100 times wider, 1.3 million Earths, 500 years. Our brains just aren't built to handle numbers this big. They're totally abstract. So to really get a feel for it, we have to stop imagining and start building.
And you don't need some fancy NASA laboratory to do this. Nope. All you need are 3 really simple things you probably have lying around. A football, a little bit of sticky tack, and a ruler. That's it. Let's build our own solar system. Okay, so in our model, this standard football, that's our sun. Pretty simple. So, what about the Earth? Well, the Earth is this tiny, tiny little ball of sticky tack, just 2 millimeters across. Seriously, take a second and picture that. This big football, and then this speck, a speck of dust, basically.
And making it is incredibly easy. You just pluck off a tiny piece of that sticky tack, roll it into a little ball that's only 2 millimeters wide, and then put it right next to the football. And that's it. That little speck, that's us. That's you, me, everyone and everything we've ever known sitting right next to our star.
So we have our sun and we have our Earth. But, size is only half the picture. Now we get to the really mind-bending part, the distance. In our little model here, how far apart do you think they should be? Go on, take a guess. A few feet? Maybe across the room?
The answer? 23 meters. Yeah, 23. That's not a typo. To put our tiny 2 millimeter Earth in the right spot, you have to move it 23 meters away from that football.
Now, what does 23 meters even look like? Well, it's about the length of a cricket pitch. Or think of it this way. Just take 23 big steps. So imagine doing that. Put the football down at one end, walk 23 big strides, then put that tiny, tiny speck of sticky tack on the ground. Now turn around and look back at the football. That's the real scale.
And here's where it gets really crazy. That massive 23-meter gap, that's just the distance to us. We're still right in the cozy inner part of our solar system. So, let's keep going, right? What if we wanted to add the furthest planet, Neptune, to our scale model? How much further do we have to walk from our football sun?
You would have to walk 30 times further. That comes out to nearly half a mile away. Can you believe that? Our football sun is at one end of a long street, and way, way down at the other end is our model of Neptune. And all that space in between? It's just emptiness, with a few other little specks like our Earth scattered in it.
There's a quote from the source material that just sums this up perfectly. Imagine trying to throw a pebble to hit your bit of sticky tack half a mile away. It sounds completely impossible, doesn't it? And that right there is the insane challenge that rocket scientists face every single day. Their math has to be so good, so precise, that they can hit a moving target, a tiny pebble, from half a mile away. So really, the next time you hear about a rover landing on Mars or a probe flying past Jupiter, think about this little model. Remember the football, the tiny speck of sticky tack, and that vast empty space between them? That's when you really understand the true scale of what we can achieve.